In the last lecture we discussed that if we take the derivative of the profit function with respect to output prices, we get the output supply function of the firm. Today we are going to discuss how can we extract factor demand function from profit function applying Hotelling lemma. So for this purpose we are assuming the case where the firm is using single input to produce a single output. So let us take the case. So this is the optimization problem where the firm is producing single output using a single input. If we apply the first order condition, we get, so this is the first order condition for the firm to maximize its profit. If we solve the first order condition, we get the factor demand function, and so the profit function becomes this. So it means that we have substituted factor demand function, that is x is the function of P and W for x only. This is because if we solve this first order conditions, we get the critical values, that is the point, the values of the factor input at which the firm produces maximum output and the profit is maximized, and the factor demand function shows the optimal level of factor inputs. So differentiating the equation number first, that is the profit function at factor demand function with respect to input price, that is with respect to W. So we get, look at it, here we apply the chain rule, P as it is. When we take the derivative of f with respect to W, actually your profit depends upon, your production function depends upon x plus x depends upon W. So that's why first of all W will change x, and then x will change your production function f of x. So that's why the story starts from the W. So that's why change in W due to change in x, right? And this change in x changes the production function. So that's why we will apply chain rule. We cannot take the derivative of production function with respect to W directly, right? So that's why we have applied chain rule over here. Minus, and this is the first function, right? And this is the second function. So if this is the first function, this is the second function, we have to apply product rule to take the derivative of this component with respect to W. So look at it, W as it is, and we took the derivative of x with respect to W plus x as it is, and the derivative of W with respect to W. So this becomes, look at it, P into change in f of x as a function of P W, its derivative with respect to x, into change in x due to change in W minus W time change in x over change in W, and minus into plus, minus x P W, and this is equal to 1, so we do not put it. So we get, if we take something common, that is this component from these two terms, right? From these two components, if we take change in x due to change in W common, so we get this is equal to, so we took this thing common, change in x due to change in W. But we know that from the first order condition, this term is equal to 0, right? P change in f of x due to change x minus W, this is equal to 0. So that's why if we put it equal to 0, right, we get this. So this term will become 0, and we are left with minus x is a function of price and W. So this is the derivation of the factor demand function from the profit function applying Hotelling lemma. This time we took the derivative of the profit function with respect to W, that is the input price, and as a result we got the factor demand function with negative sign. This negative sign means that if wage rate increase, price of input increases, it will have a negative impact on the profit. It will decrease your profit. So this is how to derive the factor demand function from the profit function applying Hotelling lemma. Thank you. Thanks for watching.